Let's take a look at the region tools. One is the Edit region tool, and the other is Edit Composite region tool. With the Edit region tool, we can define or edit the size, position, rotation, and the curvature of a region. With the Edit Composite region tool, we can do more things. We can have one or more subregions. We can also do add operation or subtract operation between the subregions. The shape of the subregion can not only be a region, but also be annulus or circle or polygon. In this example, we'll take a look at the region tool of the pattern search. So this is the search region, and we use Edit region tool. If you hit return when this cell is highlighted or just click on this cell, you can edit this region even when the status is online. So let's click on this. And now you can move, you can change the size, you can rotate, also change the curvature. When we define a window, we want to make sure it doesn't get out of the frame. Otherwise, it will be wrong. You can see the red color showing up on this bar. Okay. I would also like to show you some hotkeys. So if you hold down the Control key and hit the left or right arrow key once, then it allows you to adjust the location. So you can now you will release the Control key and still use the arrow key, the 4 arrow key, to adjust the location. Now, if you hold down Control key again and hit the left or right arrow key once more, you'll see you are allowed to change the size of this region. Now, hold down the Control key again and hit the left or right arrow key again. See, now you can change the angle, the rotation of this region. So now release the Control key, and then click on the left or right arrow key, see what happens. Okay, now let's hold down the Control key once more and hit the arrow left or right arrow key once more. Now you can change the curvature. Okay, so release the Control key and press on the left or right arrow key. Let's try. Okay, so once you have completed the editing, now you can hit the OK button or the return key to accept this change. If you'd like to abandon this change, then just hit on this cancel button or hit the escape key on the keyboard to cancel the change. We'll take a look at the trend region in this example. Right now the status is online, and now we want to use the spreadsheet. And the Edit Composite region tool is used for trend region. Click on this button and click in this area. Okay, now we can improve the region definition here, like this. And then we can also actually rotate or change the size or move around. Okay, now if you are satisfied with the change, you can click on OK to accept it. Here is an example of Edit Composite region tool. This example is from station 37 for mode 1412. The concerned area is both the straight portion and the corner portion of the rib feature. So we place a rectangular subregion along the straight edge and also an annular subregion along the at the corner of the rib feature. Now there is some tiny shot in this area, and the white blob tool detected the white blob with an area reading exceeding the maximum limit we specified in the program. So let's take a look at the spreadsheet. This is for the rib 2, the white blob. And you can see the allowed area is 10 for now. And if we'd like to pass this part, and then we have to increase the allowed area. However, the maximum allowed is 50 here. You can adjust to 50 only. So you can really pass by adjust the area only. Then now you have to edit the region if this is considered to be acceptable. And all you can do is to shift the region, right? And you can actually also rotate the region if needed. And then you can accept that. And now what happens? Okay, it's still not passed. Now the reading is 77, so it's still detecting. Now let's go to the spreadsheet again and adjust the region. Now this time we can minor tune, like just do a couple of pixels and hit the return here. And now let's see what happens. Okay, now it is passed. Okay, so there are more things you can do if needed. Let's go to the spreadsheet and click on the editing. Okay, click on the editor region, and then you can actually adjust the region individually. When you move on the subregion, you can see it's highlighted. So you can click on that, and now you can move individual. You can move the individual. You can edit the individual subregion. So you can change the size. You can change the curvature, and you can rotate. Okay, for individual subregions. After that, you can either accept or cancel that. One thing I would like to mention is that these subregions have been placed carefully and accurately along the border of the concerned feature. When problem occurs, what we want to look at first is the values that controls the pass and fail of the features. And then if you still have to adjust a region, then of course we can click on that, we can adjust. In some released programs, you can find the adjustment is limited. For instance, in this case, if you want to adjust the individual subregion, it is not allowed. But however, you can still shift or rotate the regions. With the Edit Composite Region tool, the subregions can not only be added together, but can also be subtracted between each other. Here is an example from Station 29 for 2-1907. We can see there are two subregions. One is the larger annular shape one, and the other one is the smaller polygon shape subregion. The two subregions can be edited together or individually. Now let's take a look at the major tool that we use in our accurate location search. The name of the tool is the Find Line tool. What it does is that it tries to find one or more edges along the y direction in the search region. It typically pairs with the region edit tool. So here is one pair. Here's for region definition, and then this one is the Find Line tool. Let's take a look at an example. And this is an example from station 35 for 1892. So the potential short area is here. And what we do in the program is that we train a pattern first. So the pattern is trained like this. And then we search the pattern and find the location of the pattern. And the result of the location of the pattern is shown here. And then we would like to define a search region. Take a look at the detail of the search region. You can see it's cited to cell C40 and D40, which is this one and this one, which is the location of the pattern. And then the search region is defined in this way. Let's take a closer look. You can see the search region. There is a Y direction here. And the search goes along the Y direction and should find the, and the edge tool will find the edge here. This search region can typically be adjusted. So now let's take a look at the edge tool. All right, there are certain definitions in the edge tools. Polarity. So in our case, it is from the black to white. And we want to find the first edge. The threshold can be from 0 to 100. And it's typically set to 25. Sometimes when the transition is pretty weak, we can set it to a lower number. When the transition is very strong, we can set to up to 50 or something. The edge width, typically we can set at a 3 when the picture quality is pretty good. Sometimes when the picture is slightly blurring, we can set it to higher than 4 or 5. So here you can see the found edge, and this is just the first pair of the edge search, and then we'll go to the second one. Take a look at the definition of the second region. See what it refers to. It refers to D51, the E51, which is this cell and this cell. They are the location information of the first edge. And then based on the result of the first edge, then we search the second edge and we found the location of the second edge. And then similarly, we will go to the third edge, and then we can find the result here. And finally, we do the fourth edge search, and then we find the result here. Okay. And the third and the fourth edge, they are all along this edge, so they can actually form, and the angle can be calculated based on the result of the third and the fourth edge. Now, when we define the histogram region, we can see it refers to the fixture determined by B55, C55, and A57. What's that? Let's look at that. B55, C55, which is the location of the third edge. What is F57? It is the angle based on the location of the third and the fourth edge search. So the histogram region is always accurately placed on the edge. Similarly, There are three portions in vision programs that are relevant to inspection. They are exposure adjustment, location search, and measurement. First, we'll take a look at the exposure. For some programs, there is only one exposure control in a program. For such programs, the adjustment is located at cell B1. For instance, we'll take a look at this program. This is a program for mode 1873, runs at machine 24. So for the inspection 3, usually the picture quality look like this. The part surface is white and the background is dark. And then sometime it happened that the light is too strong. Lighting is too strong, and then you can see the background is turning a little white, and it is actually saturated from the lighting. And in that kind of case, the white blob on background may be failed. So in that kind of case, in such case, we can look at the exposure at cell B1, and right now it is set at 1.0, and we can reduce it. For instance, we can reduce by 10%, so set it at 0.9, and then we'll see the picture effect. There is other cases that for each individual picture ID there are individual exposure control. For instance, this is for mode 1895, running at machine 23. So we have exposure adjustment starting from cell B13, and then 14, 15, 16. They have exposure adjustment available for each individual picture ID. Okay. Now let's take a look at the location method in our programs. We'll use the program for mode 1897, runs at station 33 as an example. We'll look at the inspection number 1. So we have a location method combined with the conventional pattern search, and also with additional progressive search method. So let's start with the pattern here. Take a look at the pattern. So this is the chained pattern. When it was chained, it was the feature was originally here. So you can see now the part is showing at a different place. And so when part moved to a different place, we want to make sure the search region still covers. So if the search region doesn't cover in many cases, we can simply adjust the search region. And then, after the trained pattern, we have a find pattern, right? We have a find pattern too. And here is the location information about the find pattern, about the found pattern, and here's the orientation information. And then we can cite the location information and the orientation information in our histogram search region. If you look closely, you can find the histogram region site to cell C40, D40, and E40. Okay, these cells. And so as the blob region. Therefore, these regions, they just, they keep up with the location of the pattern, location and the orientation of the pattern. But sometimes when it is still need to do some kind of minor tuning on those. Okay, then we have additionally, we have additional blob, black blob along the part edge, and also white blob beyond the edge. Let's see, black blob. It is this one, black blob along the part edge, and then white blob on the background surface. So if those blobs are detected, then part are considered to be failed. But these blob regions, this blob detection has been placed very close to the part edge, so they need to be located accurately. In order to locate those features accurately, we use progressive method. We use find the line tool. Okay, for those progressive search. So let's take a look at the first find line tool. It tried to find the edge here. Okay, and then if we take a look at the cells cited, it's cited to cell C40 and D40, which is the location information of the pattern. Now let's take a look at the second find line tool. So it wants to find the edge here, right? And then let's take a look at the information cited, B50 and the C50. So that is the location information of the first edge. And then after that, we have the final find line tool placed here, and it cites to cell B52 and C52. So B52 and the C52 is the location information of the last edge search. So this find location tools are progressively placed, because each tool, the location of each tool is based on the result of the previous search. And now let's take a look at the blob tool, detect the blob. So this detect the blob tool refers to the information of B54, C54, G54. Let's take a look. So that is the location information of the last edge search, and then here is the angle information of that edge. So that's the orientation. So it refers to the result, the location and orientation result of the final find line tool, right? Of the final found edge. So here we also take a look at the white blob tool here. It also refers to cell B54, C54, and the G54. Okay. So sometimes if the edge search is wrong, if the edge search can't find a location or it missed the target, then all the consecutive tools will be failed. But however, for this kind of part, it seldom will go wrong. So it doesn't really provide you an location editing for those kind of tool here. But however, in case we have to edit that, then we'll go from the first failed one. For instance, if this edge is failed, then we have to go offline in order to edit that. Then we can right-click the mouse and then we can add it to the cell graph, and then in this way we can again relocate, right? Suppose it missed the target, then we can relocate it here. Okay, we can relocate somewhere and then play. Okay, and now the everything should still work, and the nice thing is that the inspection region will still be placed exactly the same place as before, so it's repeatable. The result is kind of consistent and repeatable. But however, there's no reason such search will be failed unless like there is something white, such as the light source all of a sudden coming to here or something. Then you have to come to this step to go offline and then add it to the location. But usually it won't go wrong. So, okay. Okay, that's about the our location search method right now. So, in the last session, we've gone through the progressive location search method, which is composed of pattern search and some edge search. The inspection regions can be placed on part or on background, either based on the pattern search result directly or based on the final result of the progressive search method. Now, we're going to take a look at the measurement. The measurement tools we are going to use can be pattern tool and histogram tool and blob tools. So first of all, let's take a look at the pattern search result. The pattern search result can be used in evaluating whether pass or fail of the part. Specifically, that's the pattern score probably we're going to use. And then the score can be evaluated against the minimum score requirement. Okay. And it is actually showing here, see on the overlay, the score. And then we're going to take a look at the histogram. Now, this histogram is defined by this region here. It is on the part. So since it is on the part appears to be bright. And then, the average histogram result should be pretty close to 255, right? When shot happens, the some portion will be black, and then the average reading will become lower, right? So if we have, let's see, here is the average reading, average intensity, and then this average intensity result is evaluated against the minimum and the maximum limit of the histogram average, okay, to determine whether pass or fail for this criteria. And then let's take a look at the blob. Here is the blob region on the part. Actually, you can see the boundary is showing in green, and this means it found the blob. Okay, this is the blob tool to detect white blob here. So since the part surface is white, so it actually should find a white blob with sufficient size of the area. So let's see what we are using to evaluate in the final evaluation. Here is the area of the blob, and then the area result is cited against the minimum and the maximum area limits. in evaluating the part. Okay. And also the number of the blobs being found is also used in evaluating pass or fail of the part. So here, the region forms only one blob, right? Only one white blob. So the number of the blobs being found should be 1. So it's, the number is used to evaluate the part. In case there is some short, some area can, the blob region can be split into 2, right? The number of blob regions can be split into 2, so, it can be filled. Okay. Other than that, we have additional blob evaluation. Here is an additional white blob area placed on the part, and it is very close to the edge. And then we have, so we want to detect if there is any black blob in this region. So if there is no black blob found, then it is going to be passed. Okay. Otherwise, it's going to be failed. Another one is, the blob region on the part, on the background. Sorry. So the background is black. If there is no white blob found in this region, then it is passed. Otherwise, it will be failed. And by the way, the threshold control in blob detection can be adjusted here, right? That's the adjustment provided. It doesn't really provide you the region editing directly. So if you really want to edit the region, if it have to come to this step, you have to go offline. You have to go offline first and then go to the spreadsheet, and then you can edit the region. Edit the cell graph, and then you can edit the region. Okay. The programs running on Cognex vision systems can be classified into 3 categories based on their inspection identification methods. The first category may be understood as no inspection identification method, which means that there is no explicit identification method in the vision program. Let's take a look at the program for mode 1415 at station 13 as an example. On this part, there are different areas of concern, including the mid-tab, the upper rib, and this low edge portion, and so on. These areas of concern are distributed on different portions on the part. So we can place pattern search for each individual area of concern. And then we can also place the progressive location search tools and histogram regions and the histogram inspection for each individual concerned area. And then we can summarize the conclusion for each individual area as the conclusion for the part. So here is the structure of the program. This is the program area for interested area number 1. We call inspection zone 1, Z1, right? This is the area for this tab. So it includes a pattern being trained, and the pattern search, and the progressive search, and histogram region, the histogram. Okay, and for the other interested areas, same type of structure, similar type of structures are applied. So, and another thing we have to think about is that the location of the part can vary from one setup to the other setup, So we have to consider such kind of variation. So in order to accommodate such variation from one setup to the other, or some kind of variance from the low-bot end-of-arm tooling, we would like to place an overall pattern search. So this is in this section, it is called a fixturing pattern. So we have an overall pattern. This is a chain pattern, actually chained over on this region, chained over on those features. Quite unique for this part, actually. That's the region for the overall pattern we picked up. So quite unique. And we would like to place an search region for this overall pattern searching to be large enough to cover the possible variation of the location. And then we'll find the search result of the overall pattern. This is the location of the pattern, and the result is here. And also there is an orientation or rotation information for the pattern. Okay, so this location and orientation information can be cited by each individual search region. See, the information is cited here by this search region for the first pattern search. So we can make this search region quite adaptable to the actual location of the feature. And so to make the program much robust. So in summary, for this category, it may contain an optional fixture pattern search on the top. So this is optional. We can utilize that search, or we can just place the search directly for each individual region without referring an overall fixture. And then we have to have one or more inspection zones. Okay, so in this case we have like 6 inspection zones, right? And all the zones, they are active at all the time. So these zones are active at all the time. Okay, and when the picture changes, they are inspected immediately. They don't need, other than the camera triggering signal, they don't need any additional signal from the robot. That's an advantage of this category. Okay, so it is also quite easy to use. That's another advantage because the inspection for each concerned area is quite typical, and for every area the program structure can be quite similar, so quite easy to be used, and they are active all the time, so there is no concern of active status or inactive status. So that is an advantage. The second category is the counter-based inspection identification method. We'll start from the pictures from the mode 1892 at station 36. This is picture number 1 for one cavity, and this is picture number 2, which is for the other cavity. We can see there are quite a bit of difference between the two cavities, and therefore we can't use the method of this category to share a same pattern for the two pictures. Instead, we have to create individual inspections, dedicated inspection for each individual cavity. So inspection 1 in the program is dedicated to picture 1. And inspection 2 is dedicated to picture number 2. So each individual inspection has its own structure, including pattern search and histogram and blob, and also, of course, progressive searching method. Okay, and then at one time, when the camera shows when the camera is showing picture number 1, only inspection number 1 is activated. Inspection number 2 should be inactive, and also when inspection number 2 is activated, inspection number 1 is inactivated. So there need to be a control between the two inspections for the status of active or inactive. And this control is done with the counter at E0. And this E0 cell is controlled by the signal from the robot. So when the vision system receives an LED light on signal, the counter is reset to be 0. Then when the vision system receives a camera triggering signal, the counter is increased by 1. Okay, so with this counter, we can control the inspection status to be active or inactive. So in the program, there is a selection by this pull-down menu to set the identification method to be counter. Okay, and then let's take a look. Here there is a number here to determine the status of inspection 1. If this number is based on the counter status. So let's see. Let's take a look at the simulation here. Okay. Now the current active inspection is number 2. So when next time when the LED light is turned on, okay, at this time the counter is reset, and no active inspection at the current stage. And you can see this number at the inspection number 1 is 0. And also let's take a look at this number for inspection number 2 is also 0. Okay, so that means both of them are inactive. Now let's take a look what happens when the camera receives an triggering signal and takes a new picture. And now at this time, inspection 1 is active. Let's take a look at the spreadsheet. Now we can see this number beside the inspection number 1 is 1. So inspection number 1 is active. And if we take a look at the inspection number 2, it's still inactive, right? And now if the camera receives another triggering signal, let's see what happens. Okay, now inspection number 2 becomes active and number 1 becomes inactive. Okay, now here the number beside the inspection 1 is 0, which means it is inactive, and let's pull down C. Okay, here the number beside the inspection number 2 is 1, which means inspection 2 is active. Okay, so the overall result is based on the active inspection. Okay, it is based on the active inspection. And then if the LED light is on again, triggered on again for the next cycle, and now both inspection becomes inactive because the counter is reset to 0. And now the overall conclusion is fail because no active inspection here. Now let's take a look at the pattern-based identification method. We use the program at station 24 for mode 1875 as an example. The original image looks like this. So image 1, 2, 3, and 4. So ID 1, 2, 3, and 4. Right now it is image number 1, and the vision program figured out the active inspection is number 1. So how does it figure out? So on top of the program, there's a section for identification. This is based on pattern matching method. For instance, let's take a look at the trend pattern here. This is for inspection number 1, and the pattern looks like this. Inspection number 2, the pattern looks like this. Number 3, number 4. All right, so now the picture is the first one. So right now the first pattern has a very high score here, and the other patterns are can't matched, right? Or can't be matched. And then if we do a simulation to show the other pictures, let's turn on the film strip. Now if we select picture 2, all right, inspection 2 is activated. What you can see on the spreadsheet is that the second pattern is matched quite perfectly. And the conclusion is that the current inspection ID is 2. Now if we go to inspection 1 again, now the conclusion is that the current inspection ID is number 1. All right, now if we look further here, you can see the method of ID matching is on pattern inspect ID instead of being on counter. And then if we select different pictures, let's see what happens with this cell. So when it comes back to image number 1, this inspection becomes active. So it is based on image to determine what the active inspection is.